Hello, welcome to the fourth video in our series that should help you become a decent programmer ready to study A-level computer science at Campion. In this video we're going to look at if conditional statements. So these are things that you've probably seen before. They exist in all programming languages. They're even in Scratch, and they're kind of one of the fundamental things that are quite straightforward for people to understand. So you might have even looked at this as far back as primary school or year 7 if you haven't done any programming since. In this video you're going to be able to make decisions in your programs, which means our programs are no longer going to go from just line 1 to 2 to 3 to 4. We can jump over lines if we want to. We're also going to look at how to have more than one outcome to our decisions, and then finally we're going to look at how to have more than one criteria. So I'm going to have a quick look at the syntax beforehand. Thank you for keeping up with the videos, by the way. I know that there's probably more interesting things that you want to be doing at the moment, but I'm glad that you're putting the time and effort in now to your studies for next year, and trust me, you'll be much better off for it. So if we have a look at syntax, if you look, it's kind of looks like the English language, and it's kind of straightforward to understand. If this condition is true, then here's some statements, else here's some more statements. If we substitute the word condition and the word statements for something being true, if this is true, then do this, otherwise do this. It's actually an English almost a full sentence, isn't it? Almost a true sentence. So what we can do is we can then use that to make a block of code execute, or a different block of code execute. We don't even need to have this else part here. We can actually just jump over the block altogether. We can say if this is true, do this, and then continue onwards. But the else is quite nice if we've got a decision where there's either one outcome or another outcome. Let's get stuck into some programming. So what I've done is I've set up Visual Studio, and I've created myself an integer, and I've also created the opportunity for the user to input an exam result. So to keep in the theme of your GCSEs and A-levels this year, what I've done is I've made it so we're just going to project what outcome this student will get based on their exam result, shall we say. One thing I have done, if you can't remember how to set up a program in Visual Studio for VB, maybe what you should do is go back and look at some of the previous videos, but I have removed the parameters from main, so now it just says main open bracket, close bracket straight away, just because I think it looks a bit tidier. So we can actually use the statement that we looked at previously, and it's exactly the same as what we looked at in the slide a second ago. If the condition is mark, let's say if they get greater than 50 they pass. If mark is greater than 50, then notice it puts the end if in for me. This statement here, this condition, is called a Boolean condition. We spoke about Booleans in a previous video. It's either going to be true or false. We should know about this this symbol here, this sign, which means greater than. Okay, it's an operator, and it basically gives us a result based on whether or not mark is, in this instance, greater than 50. Okay, to get less than, it's just the chevron that goes the other way. And if you want to get greater than or equal to, we just put a little equal sign after it. Okay. Other conditions that we need to know about: if mark is equal to 50, and then in VB, if we want to say not equal to 50, it's actually greater than or less than. Okay, or two crocodiles having a fight, depending on how you want to look at it. Okay, but we're saying if mark is greater than 50, then console.writeLine will say that student passes. Okay, and if we run the program, it's a very simple program, but if I run it and look at it, enter an exam result 50, let's go 51, we get a pass. Okay, if I enter a result that is going to be a fail, which is 30 for example, we get nothing. That's because we haven't told it to do anything. We've just told it to move on to the next line. Okay, let's have a look at that happening in real time. If you want to look at the program being executed line by line, you can actually do this in VB, and it's kind of handy. It's one of the most important tools that you'll probably use over the next couple of years. If you go to debug at the top, you got this tool here called Step Into. You can press F11 as well, but Step Into lets you execute the program line by line. So as you can see, we've got our program here now with a yellow highlighted block. If I move my window so we can see the two side by side, we're going to be able to examine this program line by line. Now up at the top, I've got on my toolbar the opportunity to step into my program further. If I click that button once, the yellow highlighted block moves to the next line to be executed. So on line 6, that's nothing interesting happening there, we just made some space in memory. But line 8, we've got something to happen. So if we go look at our program, nothing's on the screen. But when we move to the next line, we see the output from line 8. Console write line, please enter an exam result. So line 9, there is no output yet, but it's going to force me to enter something because user input, console read line. So if I enter the number 30, we're going to say if mark is greater than 50, then do something. If I then jump over that, we know mark is 30 at a minute. If you look down the screen, you probably can't see this on the video, but you can see the actual contents of the variables which are being used at the moment, and the variable for mark should be 30 at the moment. If I press Step Into again, because mark isn't greater than 50, it's just going to jump over to the next line, and then we move on to end sub, we move to the final part of the program, and then that's the end of the execution. Okay, if I run the program again, you can step into it if you like with the mark being above 50, and you can see enter that block. Okay, but we've got our completed execution there, and it just lets you see what's going on in the program. If it's not giving the desired outcome, not what you're expecting to happen, then you can have a look at it line by line and kind of work out for yourself what's wrong. So if they don't pass, they fail obviously, don't they? So let's say else console.writeLine fail. So this time if I run the program, if I type in 30, I get the message fail. Okay, if I type in 51 or 60 or whatever, I should get pass. What happens if I type in exactly 50? Before I press enter, think about it. Is it going to tell me I'm going to pass? Is it going to tell me I'm going to fail? You should have guessed that it's going to say fail. Okay, that's because the condition on line 11 is that it's got to be greater than 50. 50 is equal to 50. So if I want to include 50 in my grade boundary, I need to do greater than or equal to. Okay, that means anything less than 50 is going to be fail, which is also interesting because it means that, and this is a concept that a lot of people forget about, the exact opposite of greater than is less than or equal to. Okay, because you need to always think about what happens if I get exactly on the grade boundary. Okay, so what about if there are more than one outcome? What about if it's not a pass-fail situation? It's like your A-level where you're going to get A star for a certain grade, A, B, C, all the way down to E, and then below that a U or a fail. What we can do is we can use else if. So let's change this slightly, and let's say if they get greater than 90, nice high grade boundary, be aspirational, we'll say you get an A star. Okay, else if mark is greater than or equal to, let's say 75, then console.writeLine, you get an A. Okay, and we can continue with as many of these else ifs if we like. I'm actually just going to copy and paste them. Never ever ever write out the same bit of code over and over again. Okay, if you're doing something repetitive, then you're probably missing a way that you can do it a lot easier. Let's say you need 60 to get a B. I think that's quite generous, isn't it? Let's say you need 50 to get a C. Let's give a D at 40. And let's say you need to get 30 to get a E. Anything else is going to be a fail. How am I going to do that? Well, I could say else if it's less than 30, but all of those conditions that are less than 30 can just be summed up by saying, well, that's the only other outcome, isn't it? Else. Okay, else, big part, I don't need to write the condition again. Console write line fail. Let's call it U, because that looks a little bit less stressful, doesn't it, if we see a U rather than the word fail. Okay, so if we run the program, let's see what happens. If I enter 91, it should be giving me an A star. Okay, if I enter 54, what should be the outcome? It's a C. Okay, and there we go. If, else if, else. We've got multiple outcomes from one statement. There is one thing which I see people do over and over again, is that they forget else if. Okay, look what happens. It starts indenting itself. Okay, it also starts giving a red underline, which means there's some sort of error going on somewhere. Okay, that's because there's no end if. Okay, and you can trace the way down the dotted line to see where the end ifs are that correspond with the ifs. Okay, you can do it like this if you like. Okay, you're going to need to change the logic slightly, because if I did end if 90 gives me an A star, and end if and I'll tell you what, I'll delete all of these parts for now just so we can see this. If it's greater than 90, I get an A star. If it's greater than or equal to 75, then I get an A. Let's run this program and let's give me 78. So 78 should be an A. Okay, and it gives me the A as it predicted there. Let's run it and give me 95. It's giving me an A star and it's giving me an A. So I've actually gained 2 A levels from my 95%. That's obviously wrong. Okay, and it's because the logic's wrong. It's because you only need one of them to be correct at that stage. Okay, now if we want to have multiple criteria, we could actually use these separate if blocks. It'd be a bit messy, but it's a nice way of demonstrating putting multiple criteria into it. For an A star we need over 90, but to get an A we need to be between and including 75 and less than 90. So we can use the word and, just like the English language. If the mark is greater than or equal to 75 and mark is less than 90, then they get an A. The common error that I see is this. If the mark is greater than or equal to 75 and less than 90, then console write line A. If you read that out in plain English, that sounds like that makes sense. The computer's not clever enough to know that. Okay, the computer needs to see a full Boolean expression either side of that word and. So if I just put the word mark in there, then we know that's going to make sense. If I run that program, enter an exam result, let's try 95 this time, it gives me the A star because I've not successfully met the criteria for line 14 if mark is greater than or equal to 75 and mark is less than 90. That is, in a nutshell, how to make decisions in your programs. So what we're going to do is we're going to have a look at some exercises. I'm going to bring them up. Okay, there's actually 5 for you to attempt. I probably won't go through all of them afterwards, but I want you to write a program that will read in a person's age and display a message of whether or not they are old enough to drive. Be careful with the condition, because you don't want to make people that are younger than the age to drive able to drive. Okay, because that probably wouldn't be very sensible. And in case you don't know, you need to be 17 to drive. In question number 2, write a program which tells me whether or not a number is equal to 0 or is not equal to 0. That's probably easier than question 1 actually. Write a program which asks the user to enter 2 numbers and displays a suitable message if the 2 numbers are the same or are different. Okay, and then a slight adaptation of that, but a similar principle. Write a program which asks the user to enter 2 numbers and displays the larger of the 2 numbers. If the numbers are the same, it doesn't matter which one is displayed. Okay. And then finally, write a program which will let the user enter a denary number. Denary just means decimal, base 10 number between 0 and 9, and then displays the binary equivalent using 4 bits. So if they enter 5, they get 0101. Hopefully you remember how binary works. If you don't know, you can still do the same question and you can look it up. Or you could make it so they enter a number in from 0 to 9 and it tells them how to say the number in French or Spanish or something. Okay, I'm going to do question 1, question 3 and question 5 for you. So pause the video, have a crack at it, and hopefully you will be able to become pros at making decisions in your programs. Good luck. Welcome back. So I'm going to have a go at doing exercise 1 to begin with. So write a program which reads in a person's age, tells me whether or not they're old enough to drive. or not. Okay, kind of straightforward, very similar to the program that we did with the age. With the mark. I'm going to declare my data first of all. Please give it a sensible name. Okay, one of the principles we spoke about in earlier videos: sensible names for variables. So dim age as integer. Integer is best data type for now for us to use. So give the user something as a prompt. Console write line, enter your age. Don't let them guess. Okay, you always need to program to assume the user doesn't know what they're doing. Age is equal to console.readLine, which lets us take some user input. So we're going to say if the user is older than 17 or older than or equal to 17, then they can drive, otherwise they can't drive. Straightforward stuff. If age is greater than or equal to 17, then console.writeLine, okay, I'll put a 9 in there, console.writeLine, you can drive, okay, else console.writeLine, you are not old enough to drive yet. Okay, you could expand that if you wanted by adding in another couple of lines which could calculate how many years they've got left. Okay, so take age and subtract it away from the target and then just output that on the screen. See if you can do that. That might be a nice way of building in a previous lesson. Some of you might have also got a solution where it said if age is greater than 16. That's exactly equal to what I had on the screen a second ago. Greater than 16 is exactly the same as greater than or equal to 17. Okay, all programs that have the same outcome are as good as one another. Okay, so don't worry about it too much if you come up with a slightly different solution. As long as it works, that's what I want to see, especially from my novice programmers at the start of A-level computing. So that's question 1. Question 3 was for us to write a program which asks the user to enter 2 numbers and then displays a suitable message. So let's start from scratch. Let's declare 2 numbers, dim number 1 as an integer, dim number 2 as an integer. What I'm going to then do is get the user to enter 2 numbers, console.writeLine, enter a number. I'll give it a number so we can tell which number it is. Number 1 equals console.readLine, and then I'll do console.writeLine, enter a number 2. So number 2 is going to be set console.readLine. Beautiful. So we can then move on to our if statement, which is going to take these 2 pieces of data and compare one another to tell me which one is greater than the other. Okay. Oh no, it's going to tell me if they were the same or different. I'll tell you what, well, let's do question 4 instead, because it's kind of similar, but you might get a bit more out of it. So what we're going to do is we're going to say which of these is the greater number. So if number 1 is greater than number 2, then console.writeLine, we can say number 1 and is the greater number. Remember this and lets us join 2 strings together. Okay, you don't need to cast this as a string like you would in language like Python. It should just work out for you that you want to attach that number to this string here. So number 1 is the greater number, and then what we can do is we can say else if number 2 is greater than number 1, then let's copy out that block, give it a paste, and we can just replace number 1 with number 2. Number 2 is the greater number. If they're equal, it says in the question you don't need to worry about what happens, but it'd be quite nice if we just said else console.writeLine numbers are equal. You haven't managed to enter a number which is greater than the other one. Okay, so that is a simple solution, and we'll just quickly run it and test it and see what happens. Enter number 1, 5, enter number 6, 6 is the greater number, and if we enter the same number twice, let's do 10 and 10, the numbers are equal. Sorry if you didn't see that on the screen. Okay, that is the solution to number 3/4, and then number 5 becomes a bit long, but we need to have a way of taking a user's input. So dim number as integer again. Okay, if number is equal to 0, then console.writeLine, and we can just write out the binary equivalent of it. Okay, it's a bit of an anticlimactic solution actually, because it sounds like it's going to be a bit more interesting than it actually is. Else if number is equal to 1, then console.writeLine 0001. And what I'm going to do is I'm just going to complete the program and I'll fast forward it, and then I'll catch you on the other side for some basic error handling. So I'll see you in a minute. Okay, so that is our program. If the number is equal, oh no, I haven't got the user to input it. Sorry, what am I doing? Console.writeLine, enter a number. Never leave the user guessing. Okay, even in your practice programs, just get into the swing of doing it this way. Number equals console.readLine. So if the number's 0, it outputs the binary for 0. If it's a 1, it does a 1. If it's 2, all the way down to 9. What about if the user doesn't do what you asked them to do? What about if they put in 10? Our program's going to do nothing. So what we can do is we can put an else on the end, which will catch all of the problems. Okay. Console.writeLine. The number is not between 0 and 9. What about if we want to say, well, actually, your number was too small or your number was too large? Let's use else if in that instance. We could say console. So, beg your pardon, we can use else if number less than 0, then console.writeLine, your number was too small. And then we could also say else if number greater than 9, then console.writeLine, your number is too large. Okay, and we've got some sort of sensible error handling. Okay, never assume that a user is going to be able to do everything you ask them to do properly without making a mistake, and the more errors you can catch, the better your programs are going to be. They're going to be more robust, which is something that we're looking for when we're writing good programs. So I hope you got something out of that video. The next video is going to be quite a short one. It's going to be about an alternative version of a selection statement, something you could use for things like the last question actually, where there's multiple outcomes. Things like menus, might want to use it, which is called a select statement, which is something which is in VB. It's not in all languages, but it's something that you might make use of in VB. So I'll see you then, and then after that we're going to look at adding repetition into our programs. Thank you and goodbye.